Welcome, fellow travelers through the cosmos to million-mile microscope. Today we turn our gaze towards a celestial ballet of breathtaking proportions, a dance of ice and dust around a ringed giant. We're talking, of course, about Saturn and its iconic rings. But what if I told you that this majestic spectacle, a fixture in our night sky for as long as humans have looked up in wonder, is slowly fading away? Join me as we explore the science behind this vanishing act, the forces at play, and the implications for our understanding of this magnificent planet. Saturn's rings, once thought to be permanent fixtures, are actually quite ephemeral on cosmic timescales. Observations, particularly those from NASA's Cassini spacecraft, have revealed that the rings are slowly but surely raining down onto the planet. Imagine a cosmic waterfall cascading from the heavens, but instead of water, it's ice particles, the very building blocks of Saturn's rings. These particles, some as small as dust grains, others as large as houses, are caught in a delicate gravitational balancing act. They're constantly being pulled towards Saturn by the planet's immense gravity, but their own orbital velocity keeps them aloft. However, this dance cannot last forever. Various forces are conspiring to disrupt this equilibrium, causing the rings to slowly drain away like the last drops of water in a bathtub. The demise of Saturn's rings is not some distant cosmic event that our descendants will observe through their super telescopes. It's happening now, and we have a front row seat to this celestial spectacle. NASA scientists, analyzing data from the Cassini mission and ground-based telescopes, have made a startling prediction. Saturn's rings will no longer be visible from Earth by the year 2025. That's right, within our lifetime, those iconic rings, a staple of backyard telescopes and astronomy textbooks, will fade from our view. The process is gradual, with the rings becoming fainter and less distinct over time. While this might seem like a loss, it's also an opportunity. The very fact that we get to witness this relatively rare event, to study it and learn from it, is a testament to our place in the grand timeline of the universe. So how exactly are Saturn's rings disappearing? The answer lies in a process that's both destructive and surprisingly beautiful: ring rain. The particles that make up Saturn's rings are constantly colliding with each other. These collisions generate friction, which in turn produces heat. This heat vaporizes the ice that makes up the rings, turning it into a diffuse plasma. Guided by Saturn's magnetic field, the charged particles spiral inwards towards Saturn, eventually falling into the planet's upper atmosphere. It's a process that's been happening for millions, if not billions of years, slowly but surely draining the rings of their material. While Saturn's magnetic field and the ring particles' own interactions play a role in the ring rain, there's another, more distant player in this cosmic drama: our Sun. The Sun emits a constant stream of ultraviolet radiation, or UV light. This UV radiation interacts with the ice particles, imparting energy to them. This energy boost can knock electrons off the ice particles, creating that charged plasma, making them susceptible to Saturn's magnetic field. The UV radiation can also directly heat the ice, contributing to its vaporization and fueling the ring rain. Even from millions of miles away, the Sun exerts its influence on Saturn's rings, playing a crucial role in their eventual demise. The process of ring rain, this slow, steady downpour of icy particles from Saturn's rings, is not a recent phenomenon. It's been happening for as long as the rings have existed, a constant reminder of the impermanence of even the most seemingly eternal structures in our universe. The rate of ring rain isn't constant. It can vary depending on factors like solar activity and the angle of Saturn's rings relative to the Sun. During Saturn's equinox, for example, when the rings are edge-on to the Sun, the ring rain is thought to intensify, but even with these variations, the overall trend is clear. Saturn's rings are slowly but surely vanishing. Some estimates suggest that the rings could completely disappear within the next 100 million years. As if the slow disappearance of Saturn's rings wasn't intriguing enough, there's another layer of mystery to this celestial ballet: the appearance and disappearance of strange, transient gaps within the rings themselves. These gaps, some spanning thousands of kilometers, appear as dark streaks against the bright backdrop of the rings. They were first observed in the 19th century, leaving astronomers baffled. These gaps, it turns out, are not permanent fixtures. They come and go, appearing and disappearing on timescales ranging from hours to years. The appearance and behavior of these enigmatic gaps in Saturn's rings are further complicated by the planet's equinoxes. Saturn, like Earth, experiences equinoxes roughly every 15 Earth years. During an equinox, the planet's rings are tilted edge-on to the Sun. As the rings approach equinox, the gaps become more pronounced, casting long, dark shadows across the ring plane. This enhanced visibility is due to the low angle of sunlight striking the rings during equinox. The shadows cast by the gaps become elongated, making them more noticeable from Earth. This phenomenon provides astronomers with a unique opportunity to study the gaps in greater detail. While the gravitational influence of moonlets explains some of the smaller, more transient gaps in Saturn's rings, the larger, more persistent gaps, those that stretch for thousands of kilometers, require a more powerful explanation. This is where the invisible hand of magnetism comes into play. Saturn possesses a strong magnetic field generated deep within the planet's core. This magnetosphere interacts with the charged particles within Saturn's rings. These interactions could be responsible for creating some of the larger gaps. One theory suggests that the magnetic field lines can become twisted and tangled due to the interaction with the rotating ring particles, pushing them away and creating a gap. As we explore the mysteries of Saturn's disappearing rings, we find ourselves drawn to the planet's diverse and intriguing moons. Among these icy worlds, two stand out as potential havens for life: Enceladus and Titan. Enceladus, a small moon with a diameter of just 500 kilometers, might seem like an unlikely place to search for life. However, beneath its icy surface lies a hidden ocean of liquid water kept warm by tidal forces from Saturn and its other moons. In 2005, the Cassini spacecraft detected plumes of water vapor erupting from Enceladus's south polar region, evidence of this subsurface ocean. These plumes could contain organic molecules and even microorganisms, hinting at the possibility of a habitable environment beneath the moon's icy shell. Titan's atmosphere, while obscuring, is also what makes it so intriguing. It's a chemical soup, rich in organic molecules, the building blocks of life. Scientists believe that Titan's atmosphere might resemble that of early Earth, offering clues about the conditions under which life arose on our own planet. On Titan's surface, beneath the hazy skies, flow rivers and lakes, not of water, but of liquid methane and ethane. These hydrocarbons, combined with the organic molecules in the atmosphere, create a unique environment that scientists are eager to explore. To unlock Titan's secrets, NASA is sending a mission to this enigmatic moon Dragonfly. Set to launch in 2027, Dragonfly is not your typical spacecraft. It's a rotorcraft, a drone-like vehicle designed to fly through Titan's thick atmosphere. From the vanishing beauty of Saturn's rings to the tantalizing possibility of life on its moons, our journey through this corner of the cosmos reveals a universe brimming with wonder, mystery, and endless possibilities for exploration. As we continue to explore our solar system and beyond, we're sure to encounter even more awe-inspiring phenomena that challenge our understanding and ignite our curiosity. Thank you for joining me on this cosmic adventure. If you enjoyed this exploration of Saturn and its secrets, be sure to subscribe to Million Mile Microscope for more mind-blowing journeys through the universe. Until next time, keep looking up and stay curious.